Hey, how are you guys doing today? Today we're going to be doing catalog of parent functions and piecewise defined functions. You have to bear with me on this catalog of parent functions. Feel free to pause the video if I get going too fast because these make me excited. The constant function is simply a function that is constant over its whole domain. Okay, so what that looks like is f of x equals some number. That number can be 7, it can be -7, it can be 10, it can be 100. Since it can be so many of those different numbers, I'm going to put a C there that represents constant. Okay? And so remember, my domain, we've talked about this a little bit here. It's asking myself, what can x be? Remember, it's the bread that I'm putting into my toaster. It's what's going into the function. And so if I'm looking at this green line, I'm saying, what can x be? I'm just kind of following it back and forth. X can be anything, any of these x values going back and forth. Anything from negative infinity to positive infinity. That's going to happen a lot in these examples that we have. In your homework, it won't happen as much. The constant, or the, I'm sorry, the range on this is a little bit weird. Remember, range, we're asking what can y be? In this case, y can only be this number c right here. That doesn't quite make sense. Just hold tight. But for this one, the range is just going to be the number c, whatever number it landed at. Well, I'll introduce that a little bit better, maybe on this next one. The identity function. We got a little bit of erasing to do. So the identity function, what it looks like, we've been talking about graphing straight lines. This is the perfect diagonal line that has a slope of 1 and a y-intercept of 0. And we just call it f of x equals x. So as you can see, this thing still goes left to right all the way across from my domain. So it touches every x value left and right. And range, remember, what we're going to ask is, what can y be? Okay, and in this case, I'll give you a hint. Anytime you see arrows pointing on the end of a function, they're pointing at infinity every time. Maybe I shouldn't say every time. For the ones we're going to be doing today, yeah, every time. The squaring function. Erase part of this. The squaring function is just going to be x squared. And this is also called a quadratic. Call it quadratic, that's perfectly fine. For our purposes of what we're doing so far in here, we're going to get more depth in this later. It's just a u that is sitting on the origin. A u that's sitting on the origin. So the domain is still going to be negative infinity to infinity. I know it looks like it's going straight up right there, but I assure you it is going out to the left and to the right on that function. While the range, in this case, the smallest y value it touches on the range is right here. It is touching the y value of 0. And since it is touching 0, I'm going to put a bracket on there. And then it's pointing up to infinity. So again, I see those arrows pointing in the up direction, so it's going up to infinity. The cubic function. Cubic function. Cubic function, I like the way it looks. Some people call it the S. I don't know how that's an S. It kind of swivels in the middle like an S. But I do think it looks kind of like a snake. So I call it a snake on the plane. A snake on the XY plane. I have an arrow on each end of it, so it's going all the way to the left, all the way to the right. It's going up, it's going down. So I'm back to my negative infinity to infinity. Square root function. Oh, my bad on this. I just realized I did that. Where are we at? Square root, cubic function. Back to cubic function, there should be a 3 on there. Okay, that is x cubed. All right, now we're ready for square root function. Sorry about that. So square root function, it's not going to have that 3 on there anymore. Instead, it's going to be the square root of x. Square root of x, that's one of the smaller ones that we graph. It starts right here at the origin, and I call it the swoop. The swoop, the little swoop going up. I don't know why, that's just kind of what stuck with it over the years. But that's definitely a term that we'll use in here. When I say, what does a square root function look like? You can just tell me that's the swoop. Okay, so the domain of this, there's not arrows on each end of it. The smallest x value it touches is right here at 0. And it does touch 0, so I'm going to put a bracket on it. And then it's pointing to the right, all the way to infinity. Can't touch infinity, so we put parentheses on it. The range value is going to be the exact same. It's sitting on 0, and that arrow, I know it looks like it's leveling off, but it does eventually come up, all the way to infinity. Okay. Cubic function. I didn't leave myself enough room for this. So cube root function is going to be the cube root of x. And we can just take our swoop right here and just bring it back the other way. There's arrows on each end of it going up to the right and down to the left. Therefore, the domain touches everything from left to right, and the range touches everything up and down. And this would be my cubic function. A lot of people call it, well, now the snake's laying down. So a laying down snake on the plane? I don't know. That works for me. Last one is the absolute value function. Save this one. This one, it can be confusing. But I'll tell you what, I think, I have to go back and look, but this might be the only v that I put in any of these parent functions. Square root, cube root, square root. Might be the only v from what I can remember. And guess what? The math gods were nice enough to us that they made the absolute value function look like a v as well. And so what that looks like is absolute value of x equals x. I just throw x in jail is what it looks like. Put 2 bars on either side of it, or a bar on either side. Those arrows are pointing to the left and to the right, so it's touching everything from -infinity to infinity. But the range, it's sitting on the origin again. So the range is just going to go from 0 to infinity. Whew, I know, take a deep breath. Those are all your parent functions. It's not even all of them, but it's the ones I'm wanting to cover for now. We'll come back maybe to a couple more later on. But these are going to help me graph something called piecewise functions, or piecewise defined functions. And so the piecewise function is a function in which more than one formula is used to define the output. I'm going to tell you for right now, I'm not too worried about the domain of this. Okay, I've talked about the domain. It's going to be the union of the smaller domains. Don't worry about that right now. I'm worried about us being able to recognize a piecewise function. So they're going to give me something that is broken up into pieces, hence a piecewise function. Let's just read this example and try to figure it out. It says a cell phone company uses the function below to determine the cost C in dollars for, I don't know where the rest of that text box went, G gigs of data transfer, I guess. First up, it wants me to find the cost of using 1.5 gigs of data. 1.5 gigs. What I have to do with the piecewise function is I have to look at my input. This is my input right here. I have to figure out which piece does it go in. Okay, this is my input, this is my x. So if I'm looking over here at the x's, it wants me to use this top line, my top piece, if you will, if my input is between 0 and 2. And it wants me to use this bottom line down here if my input is greater than 2. So look at the 1.5. The 1.5 fits nicely between the 0 and the 2. So I'm going to use this top piece right here. Well, the top piece is just a constant function. So you can think of it this way. I'm going to plug 1.5 in for x into this function. Well, there is no x. So in other words, if I just use 1.5 gigs of data, they're going to charge me a flat rate of $25. Anything between 0 and 2 gigs, they're going to charge me $25. Okay. Now, the second part of this, it wants me to ask how much is it going to cost if I use 4 gigs? Well, 4 gigs fits into this bottom piece because it is bigger than 2. So what I'm going to do is I'm going to take this 4 and I'm going to plug it into this G right here. And it's going to figure it out. It's probably going to be bigger than 25 because this means I went over my data limit. Just doing some order of operations here, and yeah, it's going to cost me more than $25. It's going to cost me or my parents or whoever pays my cell phone bill $45 this month because I went over my 25, or not my 25, my 2 gig data limit. Okay. Now let's talk about graphing these. I'm just going to make some up. We've done some this morning that's worked out really well. Maybe we'll just use those. I might put one up here for you to do, and you can make sure that you're matching. Okay. So the way that these look, it has an open bracket, and it does not, I'm sorry, it's a brace. It has an open brace, and it does not close it. And for tonight, what we're going to be doing is I'm going to give you one of the parent functions. And I'm going to give you a condition on it. And I'm going to give you another parent function, or I might give you a straight line in this case. We should know how to graph straight lines. And so what I'm going to do is I'm going to look at each piece. I just take a piece at a time. It doesn't matter which one I do. I'm going to do this top one first, the x cubed. So the x cubed, if I go back and look at my notes, I see that's my boy. That's my snake on a plane. So I'm going to draw this snake on a plane. However, this is a piecewise function, so it's only going to want a piece of this function. What piece does it want? It just wants the piece that is bigger than or equal to 1. So here's 1. What's bigger than or equal to 1? It's all the numbers that are on this side of 1 over here. So if it's not on that side of 1, I'm going to erase it. Hope you're not writing in ink. I'm going to erase this all the way up to here. And so this thing's going to start right here at 1. I'm going to put a big dot there because it's okay if it touches 1 because it's or equal to. Okay? And so there's that piece, what it looks like. Let's do the other piece. This has been throwing some people off this morning. It's negative 2x plus 0. This is just a straight line that has a slope of negative 2 and a y-intercept of 0. Okay? So if I come over and plot that, let's see, 0. Rise 2, run negative 1. Rise 2, run negative 1. Or I can drop 2 and then run 1. I don't want to go too far on this because remember, I have to fit it inside this domain. X has to be less than 1. So I don't want to keep going this way on it because it's not defined over there. I just want to graph this straight line for where x is equal, or I'm sorry, less than 1. So all I'm going to do is I'm going to put an open circle right there. I'm just going to connect lines going up. And this would give me full credit. Looks really weird, I know. But we need to practice this. It'll help us understand our parent functions. It'll kind of move us into what we're going to do later. A couple things. It was less than, so I did use an open circle on that. And finally, remember, it is a function. We're going to be stuck on this whole idea of function for a while. So I'm going to make sure my end product passes the vertical line test. And yes, anywhere I graph or I plot a vertical line on this function, it comes out to only touch my graph in at most one place. Oop, I about switched slides. This is my last slide, so I'm going to go ahead. Let's try one more. Let me try to fill you out. Let's see if we remember what this function looks like. I'm not going to use inequalities this time. I'm going to use not equal to. And then 3fx is equal to. Again, it doesn't matter which one you graph first. I always start with the top. And sometimes I wish I would have started with the bottom after I realize it, but starting with the top, I'll make do. You're going to need an eraser on this either way. Absolute value function. If I go back and look at my notes, absolute value. Ooh, there's that magic V. This is the one and only function that has a V in it. Well, I'm going to graph myself a V right there. Now, it says it's fine if it takes on this value as long as x does not equal 2. Oh, where's x equal to 2? Oh, I meant to do negative 2. We can do 2. Doesn't matter. 2. All right, so I got to come down here. I'm going to erase for this thing. Oh, man, I missed. It's a big old eraser. I need to shrink that a little bit for this lesson. So what I'm going to do is I'm going to cut out this little bitty spot right here. I'm going to put a little bitty hole right there, if you will, where x is equal to 2. All right, so now, I got close on that. I hate to switch problem midway, but I'm going to put a -3 so you can kind of see what's going on a little bit. All right, so for this -3 right here, this is just my constant function. This is my f of x equals c. So that means I'm going to graph myself 1, 2, 3. I'm going to graph myself a nice, healthy, straight line right there at -3. However, this doesn't pass my vertical line test, so I know I'm not done with it just yet. The only time I want to graph x equals 3 is at the point 2, right here underneath this red 2. So I need to shrink down my line. I'm going to shrink it. Oh, ooh, that's pretty good. Shrink it all the way. I know, I erased the whole thing. I need to shrink this thing all the way down to it's a single point. That is really shrinking that line. And that's what this crazy looking piecewise function looks like. I did want to do one more with you before we go on to homework. I'm gonna let you do this one. We'll pause the video and we'll see if you can match my answer. Let's do let's do 1/2 x plus 1 up here. And let's go back to this guy. Let's do this. X. Let's not do 0. Oh, I got to. Gosh. Let's do 4. We'll do this one with x. That's less than equals 4. So hit pause. See what you can get. All right, here's my rough sketch of it. My black line was my bottom part. It was my swoop. I had to erase it. The front half of my swoop. And I just have the straight line there that I just graphed for less than or equal to 4. Okay. Good luck on the homework. And if you have any questions, make sure you ask.